Live from Boca Raton, Florida, it's the ACT, SAT Math Prep Master.
Hi students, I'm Andrew. In the next hour or so, I'm going to help you raise your ACT math score. I guarantee this is the best 1-hour preparation you can get anywhere. I went through hundreds and hundreds of past ACT math questions, and for the last 7 years, I've spent countless late nights writing my new one-of-a-kind book on how to master ACT math. It will be published soon and available to purchase on my website shortly. This video covers my one-page cheat sheet with every formula, tip, and trick that you need to know to master the ACT math. This video is for everybody taking the ACT math test. My first segment covers what I call the Gimmies. If you know these formulas, you will raise your ACT math score instantly. They are the basic logarithm equation, the equation of a circle, and the distance formula. Let's do this.
Equation of a circle, x minus h squared plus y minus k squared equals r squared, where r equals the radius and hk is the center of the circle. Let's go to number 1. What is the center and radius of a circle with the equation x minus 5 squared plus y minus 2 squared equals 25? Well, notice it's x minus 5 and y minus 2 squared, and in the equation it's also minus. So to find the center points, if these are minus, then they are positive points, and if they're plus, they would be negative points. So the center of the circle would be positive 5 and positive 2. Looking at number 1 here on the right, positive 5, positive 2. This is the center of the circle, and the radius of the circle is the square root of 25. The square root of 25, remember, equals 5. So the radius is 5, and the center is 5, 2. That means 5 units in every direction, the radius. Answer choice is D. Number 2, what is the center and radius of a circle with the equation x squared plus y plus 2 squared equals 9? Well, notice this is just x squared. Well, what's that? Instead of putting x minus 0 squared, when the coordinate is 0, the equation, you just do the x squared because the 0 would be insignificant here. So that point would be 0, negative 2. Remember, if it's plus, it's minus. So the center would be 0, negative 2, and that is shown in number 2 here. 0, negative 2 is the center of the circle, and the radius, remember, is what? The square root of 9. The square root of 9 equals 3, and that is the radius of the circle, which is 3 units in every direction from the center. So radius is 3. Answer choice E. Number 3. What is the equation of a circle centered at 4, 0 with radius 2? Well, again, this is shown at the right, number 3. And centered at 4, 0 with radius 2. And remember, if it's 4, 0, it's going to be x minus 4 for the x point because it's always the opposite. And y would be just y squared. But look at this. There's a minus sign here. Don't get fooled. It's not a minus sign in the equation, so those are out. No E, no B, no A. So answer choice has to be D because the center is 4 and 0, and the radius is the square root of 4, which equals 2. The distance formula, probably one of the most important formulas to remember on the test. When I ask high school students the distance formula, I'd say maybe 1 out of 10 actually remembers it. I hear all kinds of crazy answers because the formula sounds like the other formulas that you've learned, like the slope and the midpoint with the y2s and the x1s. So remember this formula. It's the square root of x2 minus x1 squared plus y2 minus y1 squared It's basically the Pythagorean theorem backwards, and I'll show you that a little later in the segment. Number one, what is the distance between the points 1, 4, and 4, 8? Well, using the distance formula, we have our points here of 1, 4, and 4, 8. So let's call this point 1. We'll call this point 2. This would be x1, y1, x2, and y2. And just plug that right into the formula. We'll do that down here. So it's 4 minus 1 squared plus 8 minus 4 squared. And what does that equal? Well, 4 minus 1 is 3 squared plus 4 squared, square root of that, equals the square root of 9 plus 16, square root of 25, and that equals 5. That's the distance from 1, 4 to 4, 8. It's 5 units. Number 2, what is the length of the line segment connecting the points 1, 1 and 6, 13? Let's use the distance formula again, because that's the topic we're on. Let's do that up here, because we have some space right here. And again, this will be point 1, and this will be point 2, and I'm just going to not draw them out. 6 minus 1 is 5 squared. That was 6 minus 1. Then we have 13 minus 1, which would be plus 12 squared. And that equals 25 plus 144, which is the square root of 169, which equals 13. Answer choice E. Now looking at number 1, I promised I'd show you the Pythagorean theorem way. If we were to plot the points 1, 4, which would be right 2, 3, 4, right there, and 4, 8, right there. I wanted to know the distance between those. I can draw a right triangle, like so, and do the Pythagorean theorem. That's a horrible right triangle. Oh, anyway, let's just do the Pythagorean theorem. So the length from here to here, if you notice, is 3 units. And the length from there to there looks like 1, 2, 3, 4 units. And if we do the Pythagorean theorem, that's 3 squared plus 4 squared equals c squared, which is 9 plus 16 equals c squared. So 25 equals c squared. Taking the square root of both sides, c equals 5. Well, notice, those are the exact same numbers that we have here. So it's just the distance formula backwards. Maybe that's why the distance formula guy didn't get his name mentioned like Pythagoras did. I don't know.
Logarithms. Most questions can be easily solved on the ACT math by using the basic logarithm formula. Log base y of a equals x. All that means is you take the base, which is the y, to the x power, and that equals a. Y to the x power equals a. Look at number 1. Which of the following could equal the value of x? Log base x of 36 equals 2. All that is, x to the second power, x to the second power equals 36. X to the second power, not times, x to the second power is 36. What number to the second power is 36? That would be 6. Answer choice C. Number 2. What is the value of x that makes the following equation log base 3 of 9 equals x true? Same deal. 3 to the x power, 3 to the x power equals 9. 3 to the x power equals 9. Well, what is x? X is 2 because 3 to the second power equals 9. 3 times 3.
Great start, students. Those are the gimmies. You just raised your ACT math score a few points. Let's get started on the next set of formulas. Remember Algebra 1? Well, you better, because they're on the ACT math. Here they are. Equations of lines, midpoint, and the slope.
Equations of lines. The slope-intercept form of a line is y equals mx plus b, where m is the slope of the line and b is the y-intercept, where it crosses the y-axis. The point-slope form of a line is y minus y1 equals m times x minus x1, where x1, y1 is any point that's on the line and m equals the slope. The standard form of a line is ax plus by equals c. And parallel lines have equal slopes, and perpendicular lines have negative reciprocal slopes. Sign change flip. What is the slope and y-intercept of the line? Y equals 3x minus 5. Well, the slope of the line is this number right here. That's the 3 because that's the m. In the y equals mx plus b, the m is always the slope. And the b is the y-intercept, which is negative 5. So it would cross the y-axis at the point 0, negative 5, and the slope m is 3. Answer choice is C. Oh, there it is, C. Number 2. What is the equation of the line in point-slope form having a slope of negative 2 and containing the point 3, 1? Well, the point-slope form is the second form here. That's the one that almost all students forget. Let's just draw that out. It's going to be, let's use this point. So the 3 is going to be the x1, and the 1 is going to be the y1. So it's y minus 1 equals the slope, which is m, which is negative 2, times x minus x1, x minus 3. Answer choice is A. Number 3, let's convert the following to standard form. Remember, standard form is ax plus by equals c, where a and b cannot be fractions, and a is always positive. So we have y equals 3x minus 5. Let's get the x's and y's on the same side, make them positive, and we'll put the number on the other side. So let's keep the 3x over here, split this equation up. We're going to add the 5 to both sides. So now we get y plus 5 equals 3x. Now simply subtract y from both sides, subtract y, and we get 5 equals 3x minus y. And we're allowed to flip the sides. 3x minus y equals 5 from the symmetric property of equality that you've learned before. Answer choice, 3x minus y equals 5 is in standard form. Answer choice, D. The slope formula, y2 minus y1 over x2 minus x1. Remember, the y's are always on top. Looking at number 1. What is the slope of a line containing the points 3, negative 2, and 5, 3? Let's call this point 1 and this point 2. So this would be x1, y1, x2, y2. And to the right, doing the formula, it's 3 y2 minus y1 over x2 minus x1. Remember, minus a negative is the same as plus. It would be 5 over 2. Answer choice A. Going to the midpoint formula, x1 plus x2 over 2 is the x point, and y1 plus y2 over 2 is the y point. Looking down at number 1, what is the midpoint between the points 1, negative 4, and 5, 0? Using the formula, 1 plus 5 would be the two x values. We'll call this point 1. Point 2 Say that's x1, y1, x2, y2. It's going to be 1 plus 5 over 2 and negative 4 plus 0 over 2. 6 over 2 is 3. And the y value, negative 4 plus 0, or the y point, would be negative 2. Negative 4 over 2. Negative 2. 3, negative 2 would be our midpoint, or point in the middle. Answer choice E. Number 2. If one of the endpoints of a line segment is negative 2, 5, and the midpoint is 0, 1, what is the other endpoint? Well, this type of question is a famous one on the ACT Math, and it's easiest to not use the formula. I'm going to show you the technique now. The left endpoint is negative 2, 5, and the midpoint is 0, 1. So if the left endpoint is negative 2, 5, and the midpoint is 0, 1, which would be the point in the middle, we simply count from negative 2 to 0. We're moving up 2 units from negative 2 to 0, so we move up 2 more units to 2. From 0 to 2 is up 2 units. From 5 for the y points, from 5 to 1, we went down 4. 5 to 4 to 3 to 2 to 1. That's down 4. So now we go down 4 more. 1 minus 4, down 4 would be negative 3. And that's the other endpoint. B. Well, there you go, students. That point-slope form will always get you. Next up, your basic geometry formulas. The area of a square is side squared. The area of a rectangle is length times width. The area of a triangle, 1/2 base times height. The area of a rhombus is 1/2 times diagonal 1 times diagonal 2. The area of a trapezoid is 1/2 the height times base 1 plus base 2. Number 1. What is the area in units of the triangle below? Area of a triangle is 1/2 base times height. The base is 6. The height is 6. Simply 1/2 base times height. 1/2 of 6 is 3. And 3 times 6 is 18. Answer choice A. Number 2. What is the area of the trapezoid below? This is a fill-in. I know there's no fill-ins on the ACT Math, but this is a teaching segment. So just learn how to do the area of the trapezoid. It's 1/2 the height, which is 1/2 of the height. Here's the height, which is 4. So 1/2 of 4 times base 1 plus base 2. Well, base 1 is 6. Doesn't matter which base 1 and base 2 is. And base 2 is 12. 1/2 of 4 is 2. Times 6 plus 12 is 18. Answer number 2, the fill-in, is 36. There you go. In square units, what is the area of a rhombus with diagonals of length 6 and 7? Area of a rhombus is 1/2 times diagonal 1 times diagonal 2. 1/2 of 6 is 3, and 3 times 7 is 21. Answer choice C. We'll leave the square and the rectangle up to you. I think most of you know those two formulas. But just remember, the square formula and the fact of a square is used a lot in the ACT Math. When they mention there's a square, just remember all sides are equal. Volume of a rectangular solid equals length times width times height. Always 3 dimensions when we talk about volume: length, width, and height. Volume of a cylinder is pi r squared h, where r is the radius and h is the height. Number 1, in cubic inches, What is the volume of a rectangular solid with length equals 5 inches, width equals 7 inches, and height equal to 1 inch? Well, formula is length times width times height, so simply multiply the numbers together. 5 times 7 times 1, which equals 35. That's in cubic inches, and the answer is D. Number 2, what is the volume of a cylinder in cubic feet with height equals 3 feet, radius equals 5 feet? Looking at the formula, volume equals pi r squared h. Volume equals pi times radius squared times the height, which would be pi times 25 times 3. Let's write that up here. Pi times 25 times 3. That equals pi 75, or 75 pi. That's the volume of the cylinder. And number 2, answer choice is A. The circumference of a circle is the length around a circle. If a circle were made of string, we cut the string and measured it on a ruler, well, the length would be the circumference of the circle. The circumference equals 2 times pi times the radius, or pi times the diameter. The area of a circle is pi times the radius square. Remember, area rhymes with squarea. That's why it's squared. Okay, number 1. What is the circumference and area of a circle with a diameter of 10 inches? Let's look at the circle to the right here. If we have a diameter of 10 inches, that's from end to end, and it goes through the middle. That's the diameter of a circle. And to find the circumference, we just use this second formula here. Circumference equals pi times the diameter, or pi times 10, which is better known as 10 pi. That is the circumference of the circle. What's the area of the circle? The area of the circle, the radius of the circle is always half the diameter, so the radius of the circle is 5 inches. That's the radius of the circle. And the area is pi times the radius squared, or pi 5 squared, which is pi 25, which should be 25 pi. Maybe they'll fix that formula someday. Okay, so 10 pi is the circumference, 25 pi is the area. That would be answer choice E. Let's go to number 2. What is the radius of a circle with an area of 36 pi? Well, number 2, we have to go backwards here using our area formula. Since we know the area is 36 pi, we could just set up the area formula. The area is pi r squared. Remember, square area. So pi r squared is the area, and this whole thing is 36 pi. Okay, so 36 pi equals pi r squared. If we solve for r, which is the radius, which we're trying to find, divide both sides by pi, that would cancel, so r squared equals 36. And to find r, which is the radius, we would take the square root of both sides. So r equals 6. Answer choice B. Well, those are the basic geometry formulas. Now for a theorem and a formula that you probably don't know. Triangle inequality theorem. The length of the third side of any triangle is always less than the sum and greater than the difference of the other two sides. Very confusing, but very simple. If you just add the two sides, the third side is less, and if you subtracted them, the third side's more. Let's try number 1. If the length of two sides of a triangle are 8 inches and 12 inches, which of the following could be the length of the third side of the triangle? Simply add the two sides together, 8 and 12, that adds up to 20, so the third side must be less than 20, not equal to it, and greater than the difference. 12 minus 8 is 4, greater than 4. So greater than 4 and less than 20 would be answer choice C, 19 inches. Number 2, if the lengths of two sides of a triangle are 4 inches and 5 inches, Which of the following could not be the length of the third side of the triangle? Well, these are not right triangles. They could be, but most students look at this question and they start to make a right triangle and do the Pythagorean theorem. That's not the case. It's not a right triangle. It may be, but it doesn't say that it is. So use the triangle inequality theorem. The length of two sides of a triangle are 4 and 5. The third side has to be less than the sum, which is less than 9, and greater than the difference, greater than 5 minus 4, so greater than 1 and less than 9. Answer choices are all good except for E. We're looking for one that's not the length, and E is not the length because it has to be less than 9. The number of diagonals inside a polygon. You can draw the diagonals inside the polygon, but remember, the ACT is a time test and you don't have that time. So use the formula n times n minus 3 over 2, where n is the number of sides of the polygon. Let's try number 1. How many diagonals are there in a hexagon? Well, in a hexagon, you may be able to actually draw this, but I don't recommend drawing it ever. Let's try. My drawing skills are not the best, as you'll see, but there's my hexagon. Okay, how many different diagonals can we draw? Well, a diagonal is a vertex to a vertex, but not the outside. So there's 1, 2, 3, 4, 5, 6, 7, 8. Is that it? Did I miss something? Oh, here's number 9. And maybe 9. Well, let's try it with the formula. How many diagonals are there in a hexagon? Well, we know a hexagon has 6 sides, so just plug it in. 6 times 6 minus 3 all over 2, which is 6 times 3, 18 over 2, equals 9. So I got it right with my awesome drawing skills. Now let's try number 2. How many lines can be drawn vertex to vertex, not including the perimeter, in an octagon? Well, here's where you definitely have to use the formula because I don't recommend trying this. I'm not going to. Just plug it into the formula. You'd be there all day trying that one. 8 times 8 minus 3 over 2. So the number of sides is 8. It's 8 times 5 over 2. 40 over 2 equals 20. 20 diagonals inside an octagon. Answer choice E. The next set of formulas, really important. You probably don't remember these formulas because you learned them the last few weeks of geometry when your teacher was rushed to get through the curriculum. It's the arc length and the area of a sector. Arc length and the area of a sector of a circle. The arc length equals the central angle divided by 360 degrees times 2 pi r. The area of a sector equals the central angle divided by 360 degrees times pi r squared. Let's try number 1. What is the length of an arc with a central angle of 90 degrees and a radius of 5 units? Let's look to the right and I'll draw this out. If we have a central angle of 90 degrees, it should look something like that. And we are interested in the length of the arc would be just from here to there. That's the length of the arc that subtends a 90-degree angle. So notice that the arc length looks like about 1/4 of the circle. So when we calculate it, that's what we get. We get 90 degrees, because that's the central angle, divided by 360 degrees, always 360, because this is the arc length formula. And we're going to multiply that by the circumference, which is 2 pi r. 2 pi times the radius.
Radius is given as 5 units. And we simplify this. 90 over 360 is 1/4 times 10 pi. 2 times 5 is 10 pi. So multiplying across, we have 10 pi over 4, and that reduces the 10 over 4 to 5 pi over 2. And that's the length of the arc. 5 pi over 2. Answer choice B. Let's try number 2. What is the area of the sector of a circle with a diameter of 6 units and a central angle of 60 degrees? Let's use the second circle here on the right, the red one, and we'll draw a 60-degree central angle. Estimate approximately right there. So that means that the central angle here is 60 degrees. And we are trying to find the area of this sector, which is everything inside here would be the area of the sector. And the way to get that is to use the area of the sector formula, which is the central angle, which is 60 in this case, over 360, times the area, which is pi r squared. Pi times the radius squared. Well, the diameter is 6 units. Be careful here, which means the radius is only 3 units because the radius is half of the diameter. So it's pi 3 squared. So that is 60 divided by 360, which reduces to a nice 1/6. And it's 1/6 of 3 squared pi, which would be pi 9 or 9 pi. We multiply across again. 9 pi over 6. And 9 pi over 6. And that reduces to 3 pi over 2. Answer choice B.
Next up, one of the biggest topics on this test. Make sure you know Sohcahtoa.
Sohcahtoa. Just a way to remember that sine equals the opposite over the hypotenuse. The cosine equals adjacent over hypotenuse. Tangent equals opposite over adjacent. And these are their inverses. The inverse of sine is cosecant. That just flips everything. Instead of opposite over hypotenuse, it's hypotenuse over opposite. Cosine is adjacent over hypotenuse. Its inverse is secant. And the inverse of tangent is cotangent. Let's look at number 1. What is the exact value of sine C? So looking at angle C, which is here. Sine is opposite over hypotenuse. Remember, opposite is always the side opposite. And the hypotenuse is always the one that's not straight, opposite the 90. So opposite over hypotenuse. The sine of C is 7/25. Number 2. What is the exact value of the cosecant of C? Well, the sine of C and the cosecant of C are inverses. We just flip this. It's the hypotenuse over the opposite, which is just 25 over 7. What is the exact value, number 3? What is the exact value of the tangent of A? Here's angle A, and we want the tangent of A. Tangent is opposite over adjacent. So the tangent of A, which is opposite over adjacent, that's the other one that's adjacent or next to. Opposite over adjacent would be 24 over 7.
The next formula everybody knows, but can you use the Pythagorean Theorem?
The famous Pythagorean Theorem. A squared plus B squared equals C squared. Does anybody know what it means? Well, when you have two sides of a right triangle, you can find the third side of a right triangle using the Pythagorean Theorem, but make sure it's a right triangle. Let's try number 1. What is the length of the hypotenuse of a right triangle given the other two sides are 6 millimeters and 8 millimeters long? Let's draw our right triangle. Not drawn to scale, of course. Sides of 8 and 6. Using the Pythagorean Theorem, the C side is always the side opposite The hypotenuse side is always the C side. It's opposite the 90-degree angle. Sides A and B are interchangeable. We can use 6 or 8 as A, 6 is A, and we can switch them. So let's go 6 squared plus 8 squared equals C squared. 36 plus 64 equals C squared. 100 equals C squared. Take the square root of both sides. C equals 10. Answer choice A. Number 2, in the right triangle ABC below, what is the length of AB? Well, the hypotenuse is 13. That's the one that's opposite the 90-degree angle. So we'll say side AB, we'll call it A squared plus 12 squared equals 13 squared. So it's A squared plus 144 equals 169. Subtract 144 from each side of the equation. A squared equals 25. Take the square root of both sides, and A equals 5. That's answer choice E. That's the famous 5, 12, 13 Pythagorean triple. What's a Pythagorean triple? These are the Pythagorean theorems used on the ACT. This pretty much covers all of them out of the hundreds and hundreds of questions I looked at. You could just memorize these and answer a couple of questions right. Look at number 2. You see 12 and 13. It's a right triangle. You know it's a 5, 12, 13 triangle. So memorize your Pythagorean triples. They'll only help you.
A really good rule of thumb when taking the ACT math is to glance at the answers. If you see a lot of answers that have radical 2 and radical 3 in them, the question is probably a special right triangle. Learn the special right triangle rules. They are critical.
Special right triangles. There's the 45, 45, 90 triangle, the 30, 60, 90 triangle in 2 different directions. Let's look at question number 1. What is the value of x in the triangle above? Well, looking at the triangle above, this is the 45, 45, 90 triangle, which is the same as the red one here on the left. And notice that both sides opposite the 45-degree angles, opposite like this, are both equal, and they're both 4. So S is 4. So this side opposite the hypotenuse, or equaling the hypotenuse, is 4 radical 2, or S radical 2. Let's look at number 2. What is the length of side AC in the triangle above? Well, this is the 30, 60, 90 triangle with the 30-degree angles on top, and that's the same as this right here, this triangle. Notice the side opposite the 30-degree angle is always the side that's x. So opposite the 30-degree angle is the x side. Opposite the 90-degree angle is the 2x side. And opposite the 60-degree angle is the x radical 3 side. So looking at our triangle for number 2, opposite the 60-degree angle is the 6 radical 3 side. So x would be the 6. X radical 3. X is 6. So the side opposite the 30-degree angle would be 6 units long, which makes the side opposite B, which is the hypotenuse here, AC, twice as big as this, 2x, which would be 2 times x. 2 times 6 is 12 units long. And that's the length of side AC.
On the ACT, the trigonometry questions are relatively easy. Learning the concepts usually will get you the correct answer. Follow the next segment. It will help you tremendously.
Trigonometric identities. These are the trig identities that you need for the ACT math. There are a lot more, but just memorize these and you'll be fine. Sine squared theta plus cosine squared theta equals 1. Tan theta equals sine theta divided by cosine theta. Secant theta equals 1 over sine theta. Tan theta equals 1 over cotangent theta. And the cosecant of theta equals 1 over sine theta. Remember, theta can be replaced by any variable.
Let's go to number 1. What is the exact value of 1 plus sine squared x plus 1 plus cosine squared x plus 1? Let's group this in a different order. Remember the commutative property of addition? Yes, you do. Let's do it. That's going to be 1 plus 1 plus 1 plus sine squared x plus cosine squared x. Just changing the order. And that's simple. 1 plus 1 plus 1 is 3. And sine squared x plus cosine squared x equals 1 from our trig identity. 3 plus 1 equals 4. Answer choice A. Number 2. What is the exact value of 1 minus cosine squared theta? Well, let's use that same identity that we did in the last question, and that should help us get the answer. So writing out the identity, sine squared theta plus cosine squared theta equals 1. Well, if we subtract cosine squared theta from both sides, we get sine squared theta, that cancels, equals 1 minus cosine squared theta. And look at our answer. 1 minus cosine squared theta equals sine squared theta. Answer choice D. Number 3. Which of the following is equivalent to 1 divided by tan x? 1 divided by tan x. Well, tan theta is sine over cosine. So let's replace or substitute tangent with sine over cosine. So we get 1 over sine x over cosine x. Remember, 1 over anything, we just flip the bottom, and we get cosine x over sine x, and cosine over sine is right here. Answer choice C.
Next up, direct and indirect variation.
Direct variation, y equals kx. Inverse variation or indirect variation, y equals k over x. Number 1, if y varies directly as x with y equals 8, x equals 4, what is y when x equals 16? Let's set up our direct variation equation. Y equals kx with y equals 8. K is just k, and x is 4. So solving for k, we find k, divide by 4, divide by 4. K equals 2. That's our constant of variation. K equals 2. So then we just rewrite the same equation, y equals kx. Plug in our k into there. So y equals 2x. And now the question asks, what is y when x is 16? Y equals 2 times 16. X is 16, so y equals 32. Answer choice D. Number 2, if y varies inversely as x with y equals 8, x equals 4, what is y when x equals 16? Well, same numbers, but this is inverse variation. Let's set up our inverse variation equation. Y equals k over x. So y is 8, k is k, and x is 4. Solving for k, we can cross multiply by putting the 8 over a 1. So k equals 32. Now we just rewrite the equation again. Filling in our k. And it says, what is y when x equals 16? Y equals 32 over 16. Y equals 2. Answer choice A.
When finding out angles in a polygon, remember these next two formulas. They're really helpful.
The sum of the measures of the interior angles of a polygon is n minus 2 times 180 degrees, where n is the number of sides. The sum of the measures of the exterior angles of a polygon always equals 360 degrees. And regular polygons have equal sides and equal angles. Number 1. What is the sum of the measures of the interior angles of a pentagon? Well, a pentagon is a 5-sided figure. And the interior angles would be this, plus that, plus that, plus that. But we could simply use the formula to add the angles. It's a 5-sided figure. So going to the n minus 2 times 180, n is 5. So 5 minus 2 times 180 is 3 times 180, which equals 540 degrees. Answer choice E. Number 2. What is the measure of each angle of a regular pentagon? Well, we know a pentagon, all the angles add to 540. If it's regular, then every angle is equal or congruent. We would simply divide that by 5 and get 108 degrees. That's the measure of each angle of a regular pentagon. We would not know the measure of each angle unless we knew it were regular like it is. So the answer is C. Number 3. What is the sum of the measures of the exterior angles of a decagon? Well, what's a decagon? Decagon is a 10-sided polygon, but that's not important because the sum of the measures of the exterior angles of any polygon add to 360 degrees. Just remember the formulas, folks, and you'll ace this test.
On the next set of formulas, we have the arithmetic and geometric sequences. On the ACT Math, they love sequences.
Arithmetic and geometric sequences. Arithmetic sequence is a sub n equals a sub 1 plus n minus 1 times d. A sub n is the nth term, a sub 1 is the first term, n is the number of terms, and d is the common difference between terms. The geometric formula is a sub n equals a sub 1 times r to the n minus 1 power, where a sub n is the nth term, a sub 1 is the first term, r is the common ratio, or the number each term is multiplied by, and n is the number of terms. Let's try number 1. What is the 33rd term of the following arithmetic sequence? So, number 1, we use the first formula here for the arithmetic sequence. This formula right there. So a sub n, we want the 33rd term. So that's n, that's a sub 33. And that equals the first term, which is a sub 1, plus n is the number of terms, minus 1 times d. Now, what is d? D is the common difference. What number are we adding or subtracting each time? That is the definition of an arithmetic sequence. Well, we go from 5 to 12, we add 7, we add 7, we add 7. 7 is our common difference, times 7. So the first term is 5, so it's 5 plus 32 times 7, which is 5 plus 224 equals 229. Answer choice D. Number 2. What is the 333rd term of the following arithmetic sequence? That would be a sub 333 equals the first term, which is a sub 1, which is the 2. The first term of the sequence, see, that's 2, plus n, which is 333, that's the one we're looking for, minus 1, right into the formula, times d. And for number 2, d is, well, we go from 2 to 5, we're adding 3 each time. 5 to 8, we're adding 3. So d is 3. 2 plus 332 times 3, which is 2 plus 996 gives us 998. Answer choice D. Now number 3 is a geometric sequence. Normally on the ACT they give you the geometric formula for almost every question I've seen, but one time they didn't give you the formula, so you got to know the formula. A sub n equals a sub 1 times r to the n minus 1 power. R is the common ratio. So let's look at this. The common ratio is what number are we multiplying by each time to get to the next number. 2 to 4 to 8, we're obviously multiplying by 2. Some questions it's difficult to find that, so we just take any number and divide it by the previous one. 4 divided by 2 is 2, or 8 divided by 4 is 2. So here, r equals 2. Plugging into the formula, the 8th term, a sub 8, equals the first term, which is 2, times r, which is in parentheses. We should put it in parentheses here. Let's change this to parentheses. Okay. To the n minus 1 power, which would be the 8 minus 1 power, because only the 2 is to the power, be 2 times 2 to the 7th power, which 2 to the 7th power is 128, and 2 times 128 equals 256. Answer choice also D.
Well, that concludes my 1 hour preparation. For more in-depth preparation, please contact me through my website at www.educatedway.com. Again, thank you for watching, and please subscribe to my channel to get more in-depth information on how to ace either the ACT or the SAT math.